Law of sines. So the first thing I want to talk about on law of sines is the oblique triangle. And as you notice here, this oblique triangle is written in this format to show you this corner is A, capital B, capital C. Now, we're going to talk about A, B to C, that area, what's going on inside of it. So when we do that, let's look at it. We have little b here, and little b is across from little b is this side here, and it's across from the angle of beta. Over here is side A, little a, and it's across from the angle alpha. And then we have little c here, which is across from the angle beta, gamma. So now let's come down here and look at some more information when we talk about these. So it says here on number 1, it says if we have one side and any two angles, it can be written as angle, side, angle, ASA, or angle, angle, side, AAS. So here we go. ASA is showing us that we have this side here, and then we have these two angles right here. This one's AAS, and it is these two sides here and then one side. The next one says, well, if I have two sides and non-included angle, we have an SSA. So meaning we have two sides and a non-included angle. So look, here's our sides, and then here's that angle. The next one says we have two sides and an included angle. So we have SAS. So here's our side, here's our angle included, and here's our other side. And then the next one just says we have three sides, which is SSS. So if you notice, it didn't include any of the angles. Okay. The next one says, let's talk about the theorem of law of sines. So the theorem of law of sines, I would definitely have this written down somewhere. And then again, here's that diagram. This one here, it's trying to draw straight, has, if you notice, has three triangles here. And on these three triangles, it's showing you how to label. So we got our height 1 here. Then we have our height 2. It's showing you how to find this angle, a gamma, and there's the gamma. Then here's beta, angle, alpha, and then it's got it labeled. Little a, little b, little c, and then you can find the area of it. Okay, so right here, I want to show you these next ones. It's kind of giving you a better insight on it. It shows that if side A, little a, is less than the height, then we have no triangle. It says if side A is equal to the height, then we have one triangle. This one says if side A falls between the height and the side B, then we have two triangles. And here is these two are a good visual of the triangles, or good examples. It says here if side A is greater than or equal to side B, then we have one triangle. It says if A is greater than or equal, or excuse me, if side A is less than or equal to side B, then there's no triangles. And this says if side A is greater than side B, then we have one triangle. Okay. So let's get started and let's work some out examples. This first example here says that you're given this triangle with information. And in this triangle, if you notice, what do we have? We have one side and two angles. Okay, so I am going to notice that I have two angles. So this is the number 1, okay, and one side. Knowing this, I'm going to start off with solving for the actual angle, the last one that we don't know, the gamma. And how do I know to do this? Well, I know that alpha plus beta plus gamma equals 180 degrees. Well, I know the 180 degrees because a triangle has angles, that all three angles in a triangle adds up to 180 degrees. Okay, so I know this. Now what I'm going to do is I'm going to plug in what I know. I know I got 73 degrees plus 74 degrees, but I don't know gamma. Well, with a little bit of math work, I can solve for it. We're going to use a little bit of algebra, and we're going to add up to 73 plus the 74, and I get 147 degrees plus the gamma equals 180 degrees. And now I'm just going to solve both sides for gamma by subtracting that 147 from both sides. Now I got gamma is equal to that 180 minus that 147 gives me 33 degrees. Now I know what gamma is, that angle. All right, now we're going to solve for side B. That's our next side we're looking for. So I know what side A is, and I know what alpha is. Remember, they're across from each other, so they go together. I know what beta is, and beta goes to B. So that's why I chose to solve for B next. So I'm going to use the theorem from above, and I just want to take a minute. The theorem was written like this. Okay. Oops. Was written where the sign was on top. And you can solve for it like this. I'm choosing to go ahead and flip it now because I'm just saving extra work later on. So as long as you do your setup right and your math right, we're going to come up with the same answer. I'm going to plug in what I know. So my beta is 74 degrees. My A is 12.8. And my alpha is 73 degrees. Now I need to solve for B, and what I notice is B is involved in this fraction. So I'm going to undo the fraction by multiplying by the denominator to both sides. All right, now that I've done that, I'm going to rewrite this right quick. So now I have B is equal to 12.8 sine 74 degrees divided by sine of 73 degrees. So now when I plug this in my calculator, and make sure you're in degrees mode. And I'm going to round to the nearest tenth. I got 12.9. Okay, so my answer for B is 12.9. Now I'm going to solve for C. So when I solve for C, I'm going to take the information I got. Again, I know that C is over gamma. We found gamma. And I'm going to take A over sine of alpha. And if you notice, I'm using what I knew from the start. This here, I'm using it here. I'm going to use it again here. It makes it easier. And plus, you know, that's what we knew from the beginning. That's my original. So let's go with it. Now, so I'm going to solve for this one. I need to solve for C. You can plug in now and then solve for C, or you can plug in after you solve for C. But I'm going to go ahead and do it now. Let's go ahead and multiply both sides by that sine of gamma to get it out of the denominator. So now I got C is equal to A sine of gamma over sine of alpha. And we're just going to plug in what we know. All right, now that I plugged in what I know, I'm going to use my calculator. I'm going to make sure I'm round to the nearest tenths, and I get 7.3. So now I know all my sides and all my angles, and that's it. Okay, so let's solve for 2. On example 2, it says this triangle with given parts, round to the nearest tenths again. We are given 2 angles and 1 side. So let's solve for it. I'm going to solve for the missing angle. So I got alpha plus beta plus gamma is equal to 180 degrees. And I'm gonna plug in, I got 13.6 degrees plus the beta plus the 116.2 degrees is equal to 180 degrees. And now I'm going to add the 13.6 plus the 116.2 together, and it gives me 129.8 degrees plus that beta. And now let's subtract the 129.8 degrees from both sides because I want beta by itself, because that's what we're solving for. And that gives me 50.2 degrees. So now I know beta. Okay, so now that I know that, what I'm going to do is solve for, I'm going to solve for either A or B first. It doesn't matter which one, but I'm going to go ahead and go with A just because the order it's in. And the reason it doesn't matter is we already know what alpha is, right? We just found beta. And we're going to use C because from the start, we know alpha or gamma and C. So we're going to use it as our original. I'm going to solve for A by multiplying by the denominator that's underneath it. It's underneath A, that's attached to A. Once I do that, now I can just plug in what I know. Okay, so let's plug in what we know. We got A is equal to 30.1 sine of alpha, which is 13.6 degrees, all divided by sine 116.2 degrees. And then we're just going to plug that into our calculator. And when I plug it into my calculator around to the nearest tenths, I get 7.9 for that side. Now let's solve for B. So I'm going to take B over sine of beta and set it equal to C over sine of gamma. And we're just going to solve for B by multiplying by what B has been divided by to get it out of that fraction. Rewrite it, clean it up, and plug in what we know. So now I got B is equal to 30.1. Sine of beta is 50.2 degrees, all divided by sine of gamma. Gamma is 116.2 degrees. Type that in our calculator, round to the nearest tenths, and I got 25.8. And that side for B is 25.8. So now I know all my sides and I know all my angles. Okay. Example 3 says determine the number of triangles with the given parts. And if we have 1 or 2 triangles, we need to give the actual angles and sides that are missing or that are unknown. Okay. So if you notice, we got these possibilities: 1 triangle, 2, or no. Okay. So what I want to do is look at what I have. I have 1 angle and 2 sides. So if I have 1 angle and 2 sides, now I need to go back and look at the rules and see what it says. And I notice here that that I have SSA, right? 2 sides, 1 angle. This is an ambiguous case. There may be 0 or 1 or 2 possibilities. We'll see. Ambiguous means open to more than one interpretation, have a double meaning, or unclear, inexact because of the choice between the alternatives has not been made. So what we're going to do is we're going to just figure it out. So if A is greater than or equal to C, then there is only 1 triangle. So let's look at it. A, in this case here, is equal to 3.2 and C is equal to 15.8. Therefore, A is less than C. Okay, knowing that A is less than C, we're going to test all possibilities by solving for the height. So let's solve for the height. And I'm going to have this formula of sine of alpha, because I chose alpha because that's the given angle, is equal to H over C. And now let's solve for H by multiplying both sides by that C, get it out of that fraction. So I'm going to rewrite this. Now I have H is equal to C sine of alpha. And let's plug in. Well, we know C is 15.8. Sine of alpha, alpha is 38 degrees. And then we're going to type that in our calculator. And we're going to find that rounded to the nearest tenths, we get 9.7 for the height. So let's look at it. A is equal to 3.2 and the height is equal to 9.7. Therefore, A is less than the height. And since A is less than height, there is zero possibilities. So C is my answer. Okay, I pause it. Okay. I paused. I just can't keep it paused long. Oh, I got news. I just wasn't gonna text it to you. Your dad. Okay, they didn't find no cancer in his bones and in his chest. His cancer doctor said she was gonna take over and not let and take care of him, not let anyone else mess with him. And he's gonna have surgery Monday on his brain. They're gonna remove the mass. Yeah. No. And they put him in his own private room. So if someone wants to stay the night, they can with him. Debbie's coming home today because she's extremely tired. She's not talking right. She said she's not even asking the right questions, which I knew she wouldn't talk to me. But anyways, she needs the rest. But once she gets the rest, she's gonna have to. Tammy and Brianna will get tired of fooling with her. But she told Tammy and Brianna that they're gonna have to help out this weekend since they don't work, because it's unfair to ask them to do it all. She did stuck it for me. And that, which I don't care to help them. She knows that. But she's not gonna let Tammy, but if you want to stay in that with them, I would have used a paper plate.
You want to shoot it on a piece of bread?
Mm-hmm. I would have used it. Anyways, so it's good news about your dad. She said he's acting better today.
Yeah.
Yeah, much better. So that's even better news. Oh, you grab the pen. So yay.
Today, thank you for this food. Yes, that's my Jesus' name.
Amen. Oh, did you go by there and find out about your money?
No.
I remember you telling me, but I can't remember everything you said. I get absorbed in this and I forget everything else. I do need to text Kendricks now. He's got that meeting or the interview at 1.
I tried to got more gas in it when I put it when I got in there.
Thank you. Okay. He asked me yesterday about how you should do in the meeting and stuff. I said Kendrick's VU. Because that's who they're gonna want is you. You know? I'm so excited for him. I told Debbie you've been checking on Tank and stuff, and he's all right. So don't worry about him. He's all right. It's okay. She just don't like him being alone. That and she don't want to be at the hospital. It may be better. I mean, you don't like being there either, so I don't like being there, but I'll do it. I do it because I'll ask questions. I'll find out stuff. I don't care. Debbie got everybody because the doctor looked at me. Tammy, I told her about that last night. And Tammy goes, it's because we're not supposed to be there. Only one person is, but they know there's a caregiver for Debbie. So that way there's someone can understand everything's going on. That's why they look at you more than they do her, because they know that I'm the one that's got to interpret it all later. And I never even thought about that. Plus, I asked a lot of questions. But yay, they'll know more about that spot in his brain when they cut it out. Yeah. They'll be able to test it and stuff, look at it and tell if it's cancerous or not. I like Dr. Goss. Mm.
I'll check on you again.
Okay, that spot's right here.
Okay.
No, on your dad.
You on top of it?
Mm-hmm. To the left a little bit. Thank you, Lord. Have you been there and back? Sleeping or something? Okay, well, I'm gonna turn this back on. So now let's go to example 4. So we're now in example 4, we're going to do the same thing. We're going to determine if we have one triangle, two triangles, or no triangles. And if you notice here on example 4, we have one angle and two sides. Okay, so now let's solve for it. Or let's first evaluate it. Let's see what's going on, okay? So we see that we have the SSA, two sides and one angle. It is ambiguous. Okay. So there may be no triangles, there may be one or two. Let's do the if possible. So if side B is greater than or equal to A, then we have one triangle, right? All right, moving on. But in this case here, let's compare it. B is 29.1 and A is 37.2. Therefore, B is less than A. So we're going to have to find the height and test all possibilities. So using this notation that we know from the formula of sine of beta is equal to the height over A. Now let's solve for the height by multiplying both sides by the denominator of A. And let's rewrite this. So now I got H is equal to A sine beta. Let's plug in what we know. 37.2 sine 38.3 degrees. Plug it in our calculator, round to the nearest tenth, and we get 23.1. So this tells me that B falls between A and H. It doesn't equal them, it just falls between them. So this tells me there is two triangles. So I know B is my option here. All right, so what I need to do now is solve for those triangles. Okay, so let's not go scroll too much. So let's solve for the two triangles. What I have is beta is the angle I have, and then I have side A and B. So we know what beta and B is. We're going to use the law of sines here. So, and we're going to solve for, and we know what A is. So let's solve for alpha. So I got sine alpha over A is equal to sine beta over B. And we're going to solve for the sine of alpha by multiplying both sides by A to undo the fraction. Now I got sine alpha is equal to A sine beta over B. However, we need alpha, right? And it's attached to the sine, so I'm going to have to take the inverse. Now I'm going to go ahead and plug in what I know. A is 37.2, sine beta is 38.3 degrees divided by sine, divided by B. I'm just looking at the word above it. And, okay, B is 29.1. We're going to type this all in our calculator and we get 52.4 degrees. All right, so now I know what alpha is. I didn't finish. No, okay, so we're good. Yes, we're gonna write it right here. My alpha is 52.4 degrees. That's what messed me up. I thought that didn't look right. So let me get it back together. 52.4 degrees. 52.4 degrees. All right. So now that I found that, I want to find gamma. Well, that's not going to be too hard to do because we know 2 degrees. And we know a triangle is equal to 100 degrees. So now, and let me just split this in half just a little bit. Kind of give me some separation on the paper. So I'm going to take the alpha plus beta plus gamma equals 180 degrees. I'm going to plug in alpha is 52.4 degrees plus my beta is 38.3 degrees plus the gamma equals 180 degrees. Now I'm going to add up the alpha and the beta. So let's add it up. We get the 52.4 plus the 38.3. That gives me 90.7 plus that gamma equals 180 degrees. We're going to subtract the 90.7 from both sides. Now I have gamma is equal to 89.3 degrees. Okay, so let's write here 89.3 degrees. Now, let's find C. So when we're looking for C, let me separate my paper just a little bit, make it a little neater. I'm going to find C. So it's sine, C is over sine of gamma. It's equal to, and we're going to use our B is over sine of beta. Let's solve for the C by multiplying by this denominator. All right, now let's rewrite this. So I got C is equal to B sine gamma divided by sine beta. And we're going to plug in what we know. I'm going to have to do a little bit of moving around. So hopefully you got this written down. And I'm running out of room. So let's finish this one up and I'll have to erase some of this. So I'm going to type it in my calculator and I'm going to, oh, first let's plug in what we know. Excuse me. So B is 29.9, or excuse me, 29.1. Gamma is 38. No, gamma is not 38. Let me separate my paper a little bit. Let me just erase. This is becoming a mess. So I apologize. Let me just erase this. Hopefully you got it all written down. Let's just erase this and give myself more room. That way it looks neater and less confusion to y'all, okay? So now let's do this. So B is 29.1 sine of 89.3 degrees divided by the sine of beta, which is 38.3 degrees. Type that in our calculator and round to the nearest tenths, we get 46.9 degrees. So I'm going to come up here, 46.9 degrees, or not degrees. Good grief, guys. My apologies. Not degrees. It's a side. C is the sine. All right, now let's, I'm going to go ahead and erase this here. Because what we're going to have to do is find the second triangle. Now that we found the first triangle, let's find the second one. Give us some room here. Let's just erase all this. All right. Okay, so now we're going to find the second triangle. Thank you for bearing with me. And what we're going to do is I'm going to solve for this alpha one first. Okay, when I solve for that alpha, and I know that we got a triangle of 180 degrees, we know that. I'm going to subtract the alpha from the first triangle, because remember they bump up. The triangles are together, right? And we're able to, to split the image in half and come up with two triangles, right? So if you need to review the first couple pages again of these notes, All right, so once I do that, I get 127.6 degrees. So now I know this angle. Now, what I want to do is solve for gamma, because that's my next angle that I'm looking for. Well, I'm going to find my gamma. I'm going to take that 180 degrees. I'm going to subtract the 127.6 degrees from the alpha. And let's go to the original beta, subtract it. And when I do that, I get 14.1 degrees. So now I know this angle of the second triangle of gamma. Now let's find C. That's the side we're missing of the second triangle. So I know C is divided by sine of gamma, and it's equal to, and let's use the B over sine of beta because it's our originals. And we're going to solve for C by multiplying everything by the denominator. And now let's rewrite it and plug in what we know. C is equal to B sine of gamma divided by sine of beta. And the side B is 29.1. My gamma is going to be 14.1 degrees, right? Because it came from our second one here. And then our sine beta is 38.3 degrees. Type it in your calculator, round to the nearest tenth, and we get 11.4 for my side C. And that's it. And thank you for bearing with me on this one. It got a little messy. I didn't give myself much page room. So I would like to do one more example, and then we'll be done with this section. So on this one here, oh, we got two more. Oh, yay. Okay. Two more. I think we only have one more. It says we have a helicopter that flies the airport, flies from the airport on a course with the bearings of 15 degrees. After flying for 95 miles, the helicopter flies due east for some time. The helicopter flies back to the airport with a bearing of 222 degrees. So how far did the helicopter fly on the final leg of its journey? So we're going to find the distance the calculator flew was approximately blank miles. Okay, so the underlying question says we're wanting to know how far did the helicopter fly on the final leg of this journey. So what I need to do is determine. So if you can ever draw an image of an application problem, it will help. Diagram, image, or charts, whatever it may be. And if you can label it correctly, it will be real useful. And as you notice here, it says 95, right? Flies 95 miles and it's flying north. You can see the arrows here on each of these vectors, each of these lines, showing you what direction. Okay. So since you want to find the distance the helicopter traveled on its return leg, and now let me highlight the return leg. So it'll be this one here, right? It's going to be on the side B. You are looking for side B in the figure. So what we need to do is we're going to have to find the segment line of AC, right? Let me change this right quick so you can see what I'm saying. Here's what I'm talking about. All right. Now, since we know the length of C, which is 95 miles, and can calculate the measure of two of the angles, let's use the law of sines. All right. So we have B is going to be, because we're solving for B, right? Right here, the last leg. Sine is divided by sine beta. And we know what C is, so we're going to use it divided by sine gamma. And we're going to solve for B by multiplying both sides by its denominator, which is sine beta. So I got B is equal to C sine beta divided by sine gamma. And we can plug in what we know, but just one second. I kind of jumped the gun. This is something we know. But I need to tell you what beta is. Beta is going to be found from A, B, C. Okay. And gamma is going to be found from B, C, A. So these are where these capital letters really come into play and help you, because it's letting you know from point A to point B, from point B to point C. All right. So you can rewrite right here. I'm gonna write one more time. B is going to be equal to C sine of A, B, C divided by sine of gamma, which is B, C, A. So this notation is important that you understand it. Now, when we find the measures of BCA on this picture here that I've got drawn for you here, let's see, let's find, let's use the purple. Okay, so on this picture here that I got drawn, if you notice this here in the blue, that there in the blue is going to be the BCA. Okay, the angle for BCA. B, C, B, C, A. So here in the blue is going to be that angle. All right. So remember the bearings of the angle on the return trip said here is 222 degrees. So knowing that, we're going to look at the green figure here, where it shows C right here. And we notice that we have the measures of due north. We have these degrees that we're trying to figure out. Well, on this green figure, if you notice, it's greater than 270 degrees. So I'm going to subtract that 222 from that. And then I'm going to know what I'm looking for, right? I know that's going to be BCA. It's going to give me my degrees here. So I know this is greater than 270. So I subtract the 222 and it gave me this blue line here. So the next part, this next image I have here, we're looking for A, B, C, that degrees. And the blue figure here, right here, is where we're going to find that degrees. All right. So to find it, I'm going to take that 180 degrees because, you know, that's what we got when we talk about a triangle. And if you notice, this is in a triangle format. We also notice here in the original problem, it says 15 degrees. So we're going to subtract that 15 degrees is the bearings there, right? And then we're going to, and that's found here in the green. And we're going to subtract 90-degree angle from this. And you agree that this fell between, if I was to draw a dotted line, the x-axis on a Cartesian coordinate unit circle, from here to the north, we know it's a 90-degree angle, so we need to subtract 90 degrees off of that. Gives me 75 degrees. So now ABC is 75 degrees. So we did great. Now we know so far what we're looking for, right? This gives me this angle here. Now let's find this one. So in order to do that, before I can say that ABC is really 75 degrees, I need to subtract it off that triangle. So I'm going to take that 180 degrees and subtract the 75 degrees, and that gives me 105 degrees. So now I know this angle. All right, we got all the angles going on. We got all the angles figured out. So now I'm going to highlight this. BCA is 48, ABC is 105, and we can just plug in what we know. Well, we know C, which is 95. Sine of ABC is 105 degrees divided by sine of BCA, which is 48 degrees. We're going to type it in our calculator. we're gonna round to the nearest tenth, and we're gonna get 123.5. So my answer is 123.5 miles. All right, so let's do the last one. The angle of elevation to the top of the tower from point A on the ground is 11.9. From a point B, 35.2 feet closer to the tower, and then the angle of evaluation is 16.8 degrees. Find the height of the tower in feet. Okay, so there's the underlying question. And if you notice here, I really should have changed these out. I was changing numbers, trying to get something a little bit different. This angle, this degree here, this angle is a 16.8 degrees, and this angle here is going to be 11.9 degrees, and then this angle here is 35.2. This it's not angle, this side is 35.2. All right, and if it be easier and it's not as messy, you can draw it over here on this other one. So we can write, this is 35.2. This angle here is 16.8 degrees, and this one's 11.9 degrees. So what are we looking for? We're looking for the gamma, little a, side B, height. Well, the underlying question wants the height. So this is what we're solving for right here. We want to know what's this height right here. All right, so let's solve for it. Well, what we can do is we can find beta. Well, we know beta is going to be minus the 180 degrees, because we are talking about triangle. And we're going to subtract. So beta's here, we're going to subtract that angle on the other side of it, which is 16.8 degrees. And we're going to round to the nearest tenth, or it's going to give us a nearest tenth. It's 163.2 degrees. Now that I know that, let's take our gamma. So remember, we got alpha plus beta plus gamma equals 180 degrees, and we need to find our gamma. So let's plug in what we know. We got alpha of 11.9 degrees plus beta of 163.2 degrees plus the gamma equals 180 degrees. And we're going to add the 11.9 to the 163.2, and it's going to give me 175.1 degrees plus the gamma. And then subtract the 175.1 degrees from both sides. And now I got gamma is equal to 4.9 degrees. So now I know what gamma is. So now that we know our angles, and you can label them all out now, we know that this is 163, this is 0.2, and then this one's 4.9. We know all of our angles. Now we just need to find the height. Okay, so what we're going to do is we're going to take our side A over sine alpha, and it's equal to our B, or excuse me, C. In this case, it's C. It's labeled a little bit different this time. We're used to putting C here and B here. But since gamma is right here, you'll see it, it changed up because C goes with gamma. So this is going to be C. Well, beta is right here instead of gamma. So be careful in the notation. So if you have to go back and remember B is across from beta, C is across from gamma. So we're going to find C sine of gamma. All right, I'm going to multiply both sides by the denominator here, so I can get A. So I have A is equal to C sine alpha divided by sine gamma. Let's plug in. Well, I know C is 35.2, sine of alpha is 11.9 degrees, and then sine of gamma is 4.9 degrees. And I'm going to type it in my calculator, round if I need to round to the nearest tenths. In this case, we get 85. So our side A is 85. All right, so we're solving for our height. So what I'm going to do now is take the sine of my degree here, my evaluation. And so this one of this other side, right? We're going to take that sine, that, because this one here is the angle involved with this side. Okay, I'm going to set it equal to h over my a. And of course, we're going to multiply both sides by a to get h by itself. So now I got h is equal to, and I'm going to plug in for a. And I'm going to type this in my calculator, round to the nearest tenths if possible. And what do I get? I get that it is 24.6 feet tall.